So today we're going to look at arrays, and an array is a data structure. A data structure is a logical structure, or really just the way data is organized in the computer. But that data is organized for efficient retrieval and efficient storage. So an array consists of a series of values. And all the values in the array are going to have the same name and the same data type. So if we had, for example, a grocery store and we had an array or a list of prices, all the values in our array they should be prices, and they'll all have the same name. So if we have an array and we name it grocery prices, we would reference every price in our list or every price in our array as grocery prices. But the way these values can be differentiated is with what we call a subscript. So let's actually look at a picture here of an array. So each element in the array will have a memory location. So let's just make up a number 200 here. So 200 would be the beginning address or memory location. And if each one of our elements in the array, now this array happens to just store characters. So each character is going to be 1 byte. So the length of each of these elements is 1. So the first one would be at location 200. The next one would be at 201, 202, because each one of these are only 1 character. But an array will also have a subscript. Now, a subscript in an array is going to start at subscript 0, and then it's going to go to 1, 2, 3, 4, 5, 6, and so forth. And we say an array allows for efficient access because, let's say, again, we have the starting location at 200, and the length of each one of these are 1. We can efficiently retrieve or calculate the location of any element in our array with just a simple calculation. So here I just wrote location equals the starting address plus the length, which is 1, times the subscript. So let's say we're trying to calculate or find C. We're trying to find the value of C. The starting address is 200 plus the length, which is 1, and the subscript is 6. So 1 times 6 is 6, plus 200 is 206. So we can do this, the computer will do this simple calculation, and it can go directly to any element in your array. In this case, it's going to go directly to 206, to location 206, which has the value of C in it. So each element in an array is known as, each item in an array is known as the element, and it occupies memory next to another element. So we call this contiguous locations in memory, because in array, each item in your array is going to live right next to the next item, which is going to live right next to the next item. So they're going to be contiguous locations in memory, and they're going to be referenced by a subscript, and they're all going to have the same name. Now, the subscript in an array has to be a positive integer. It can't be negative. It needs to be a positive integer. And again, it's going to start at 0, and it's going to go to some number. Normally it's going to be a predefined number, a number that you defined in your program. So it's going to have a set length. So this one has 6 and then 7, 8, 9. But in the program, you're going to determine or declare the length of your array. So the size of the array is also called the length of the array, and that's going to be just the number of elements in your array. The length of your array is the number of elements in your array. And in your program, your array is going to have certain syntax. It's going to have your array is going to have certain syntax. It's going to have a name followed by square brackets. And inside those square brackets is going to be the subscript. Now, here's an example of what I'm talking about. Here's an array, and it's named SumVals. The reason I know it's named SumVals is because it says it here, and every element, we're calling it by SumVals. Now remember, every element in your array is going to have the same name with a different subscript. So same name, different subscript. And SumVals at 0, remember 0 is the starting element in an array. So SumVals at 0 is going at subscript 0 is going to have the value 25. The next subscript is 1, that holds 36. The next subscript is 2, and that holds the value 47. Now, if we want to look at how this looks in software, and this is really pseudocode, but it would be similar to this in software. So SumVals at subscript 0, here they're actually assigning 25 to subscript 0. So this is how you my pointer is pointing at how you would assign 25 to subscript 0. And this is how you would assign 36 to subscript 1. And this is how you would assign 47 to subscript 2. Now, so let's just continue on. Now, let's go back to this. I would not recommend assigning values this way. Now, this is saying this assigns values when array is declared. When the array is declared. Oh, I see. I'm sorry. Actually, what this is pseudocode that's showing the declaration of an array and the initialization of an array. So here they're saying, let's declare an array called SumValues, and let's make it hold 3 elements. And it's going to hold numbers, an array of numbers, and it's going to hold 3 elements. And these are the values we're going to initialize those 3 elements to. So yeah, this is saying assigns values, but they're really initializing an array. They're initializing an array of numbers to to these values. So once you have an array declared, you can use these data items the same way as you can use other variables in a program. So if you had here's answer. And if this was called number one and number two, you could add number one and number two, and it'll give you answer. But we can do the same thing with an array, but we would say some val at subscript zero, and it'll take the value at subscript zero, add it to the value at subscript two, and give us an answer. So it would take subscript zero, which is the value 25, plus the value at subscript two, which is 47. It would add those two and move it to answer. So let's see here. I'm just trying to go through the highlights. So an ideal way to process an array is to loop through the values of an array. And we can use a for loop to do that, or a while loop. Ideally a for loop, because we use for loops when we know how many times we want to loop. And as I mentioned earlier, when we declare an array, we set it to some length. So we really know how many items are in that array. So we can use a for loop to loop through or process every element in an array. So some programs will declare the size of your array as a constant, and a constant has uppercase letters here. Here they're calling it array size. So they're declaring an array of 6 values and they're setting the length to 6. Now, we're not actually showing that. I'm not actually showing that anywhere, but we're just pretending we have an array somewhere and the length is going to be 6 and it's going to be a constant. Now, that's one way of doing it in a program. A better way is really like, for example, in Java, that constant, instead of declaring it and setting it to some length, let's say you have an array element again of 6, instead of doing that array size equals 6, we would just use the built-in constant. So Java has a built-in constant. So here they're saying they have an array named count. So to use the built-in length of the array named count, you just say dot length. So count dot length. Array name dot length will give you access to the built-in constant. In C#, it's also dot length, but it's an uppercase L. And other languages have these built-in constants for the array size. Now here's an example of declaring an array of strings. So this is going to hold the months of the year. So we would have 12 strings. And so we're calling the array name month. And we're saying it's going to hold 12 values. And then we're initializing those 12 values. Again, this is pseudocode. This is not actual code. So let me continue here. A linear search is to search through an array one element at a time from the beginning to the end. So we could use a for loop to do that, as I mentioned earlier. A for loop is an ideal candidate, loop type candidate for looping through a list. Now here's I want to pay close attention to this pseudocode here. Now this pseudocode is going to search an array, and that an array that stores the valid item numbers to find the match to the ordered item. So we're going to have, here we have item numbers 106, 108, 307, 405. And right at the top, we're just going to say this, we're going to put class, and the class name is find item. So this is a class. Remember, object-oriented programming, we have classes. So we have the class name, and then in class. And this class has a method called main. So they're putting all of their statements in the main method. Now, we usually don't write all of our statements in the main method. We write our statements in another class that's not the application or the main class. So, but let's just go with what they did here. So then they have the declarations, and they have several declarations, and this double forward slash comment that says the declarations will follow. So they're going to have a number called item. Now, this uppercase size means it's a constant. So the size is going to be 6. And here they're saying this array named valid item is going to have 6 elements in it, because they're using this constant size, which is set to 6, to tell us that, or to declare that this element length is going to be 6. Then we have a number called sub. Now I like to use int I, but they're calling it subscript, but I use I for index here. And then they declared a string called founded, another string called the message yes means the item was found or the item was available, and then no means the item was not available. So they have all these declarations. Then the first thing they do is they prompt the user to enter an item number. So the user is going to enter an item number, and this program is going to search for that item. It's going to search the array to determine if that item was found or if it's available. So enter the item number. We're going to get that input from the user, and it's going to be sitting in this variable that was declared called item. So then we're going to set our array to 0, because remember, we start our array subscript starts at 0. So they're going to say, let's start searching at the very first element in the array. Now we're going to use a while loop. So we have a while, and there's the end while to match. And notice the while is aligned with end while, and then they indent to show which statements are inside of that while loop. So while sub is less than size, sub is 0 right now. How do I know? Because they just set it to 0. So while sub is less than size, what is size? Size is 6. So as long as sub is less than size, we're going to ask if what was input, remember item was input by the user, if the item is equal to the value at the array and at that subscript. Right now it's at 0. So valid item the first time through is sitting at 106. So whatever was entered, is it equal to 106? If it is, say, hey, we found it, we're done. If we find it, I'm assuming they're going to be done. So if we found it, we're going to add 1, and we're going to end while. And actually, we're not done. We're just going to continue looping. So then we're going to come back and we're going to, sub is now 1. If it's equal, if 1 is less than size, which is 6, we're going to search the next element and the next and the next. But we found it, let's just say 106 was what we were looking for. We found it. So after we continue looping, we're going to ask, hey, did we find it? If we did find it, we're going to set the message, hey, the item is available. If we didn't find it, we're going to output the message, item is not available. And the last thing I wanted to cover is parallel arrays. A parallel array is when you have two arrays and they're related. So, for example, let's say you have item. We just looked at this item array, and each item has the item number. But let's say each, in our grocery store scenario, let's say each item has a price. So item number 106 has a price of 59 cents. Item 108 has a price of 99 cents. Item 307 has a price of $4.50. So parallel arrays are set up so every value or every element in array 1 has a corresponding value in array 2. So every value in array 1 has a corresponding value in array number 2. So subscript 0 has the value 106 for the item array, and its corresponding array is going to be a price array, and that's going to be set up to have subscript 0 and a price of 59 cents. So every item has a corresponding price. The subscripts are going to be the same. So when you loop through a list, you can actually have two lists, corresponding lists, and you can point to the item. Hey, we found the item that we were looking for, but guess what? You're going to be sitting at subscript whatever, and you're also going to be pointing to the price of that item. So you found the item and the price at the same time because the subscripts are going to be the same when you have parallel arrays. Every value in array 1 is going to have a corresponding value in array 2. So I will, we'll make this the last slide. So let's say the variable I is declared as the subscript in an array called valid item. So the book has been using sub. Let's say I'm going to use I instead. So valid item at subscript I would be sitting at valid price at subscript I. So when you're looping, you're using a subscript, and we say something like for I equals 0 while I is less than valid price dot length I plus plus. What we're doing is we just set up a for loop, and now we're going to loop through each item, each array item, and we would be pointing at that price if we have parallel arrays set up. So let's just make that the last slide. I know there are other slides in here, but I'm going to stop here. So thank you for joining me.